So the long answer section of the SAC, um, they'll all have, they might have different marks. So the amount of marks is specified at the top there. And I've made sure that every question can be answered simply by typing. You don't need to draw any matrices or anything like that. You can get all your answers in just by typing using the regular functions on your keyboard. We've got a travel company that has 5 employees. The company allows each employee to send a direct message to another employee only as shown in this communication matrix. We also have the G squared matrix here. We should know what the ones and zeros refer to, but we'll reiterate. So for example, a 1 in row E column D, so this one here, means that Alka, as the sender, can send a direct message to Dana, the receiver. But a 0 in row E column C means that Alka, as the sender, cannot send a message directly to Cheng. So the question is, to whom can Dana send a direct message? Well, we go to Dana as the sender. The only ones we have are in column B and E. So our answer would be Ben and Alka are the only people that Dana can send a direct message to. 1B says, Cheng needs to send a message to Alka, but can't do this directly. So write down the names of the employees who can send a message from Cheng directly to Alka. So we want to go from Cheng to Alka. So let's look here. Cheng can send a message to A, to B, and to D. That's who Cheng can send a message to. Now, we want to see who can A, B, and D send their messages to. And we'll see who can send a message to Alka on Cheng's behalf. So let's see who A can send a message to. A can send a message to B, C, or D. B can send a message to A or C. And D can send a message to B or E. So what we're trying to find is Cheng wanted to send a message to Alka. So the only person, so Cheng can send a message to A, B, or D, and the only person who can actually send a message to Alka is D. So our answer would be Dana. So we've got a school canteen selling pies, rolls, and sandwiches, and we've got the number of each item sold over 3 school weeks shown in this matrix. First question for 1 mark is how many sandwiches were sold in the 3 weeks? This question is just asking you to understand what this information actually is, just understanding what the matrix is. So, for example, this 60 tells us the number of sandwiches, so S sold in week 1. Then in week 2, they sold 43 sandwiches. Then in week 3, they sold 56. So in total, the equation that you're doing is 60 plus 43 plus 56. And that gives you 159. Now, because this is a 1 mark question, I don't actually really need to see your working out there. If you just put 159, that's fine. To B for 1 mark, the element in row I, column J is Mij. All right, we knew that. What does element M12 indicate? So let's locate element M12. That is row 1, column 2. So it's this 24. So what this indicates is It is the number of roles. See, we're in column R and we're in row 1, which is week 1. So it's the number of roles sold in week 1. To C, we've got this matrix equation here, where A is the cost of a pie, B is the cost of a roll, and C is the cost of a sandwich. We want to find out what is the cost of a sandwich. So essentially what we need to do is we need to solve for A, B, and C. Now, hopefully, immediately we can recognize that this is a system of linear simultaneous equations. Let's check our notes for simultaneous equations and how we can solve them. So remember, the key thing about solving simultaneous equations is this line here. If we can write it as AX equals C, then we know X is the inverse of A multiplied by C. So where this is our A matrix, this is our X matrix. So that's A, that's X, and that's our C matrix. If we want to find out what the elements of X is, we need to get the inverse of A and multiply it by C. And that's something that we can do in our calculator. So first I'll write in our A matrix so that then we can find the inverse. Now, every time I do a calculation, I'm defining the variable. That is easier to do because I am on a laptop. I'm typing it in, so it's a bit quicker for me. I still recommend that you do that because it can help you. It's just more organized. There's less risk of you getting confused. But if you're confident in your ability to kind of do these equations without having to define the variables, by all means, it is up to you. I find it easier doing it this way. So the inverse of A multiplied by C, we've got the cost of a sandwich, which is our variable C, which is the last element in this column matrix. So it is 3.8. Now, 3.8, I would probably give you 1 mark for that answer. You need to keep in mind what we're actually talking about. It's the cost of a sandwich, so it's $3.80. It's not $3.8, it's $3.80. Just be mindful of that. We've got a toll road is divided into 3 sections, E, F, and G. The cost in dollars to drive one journey on each section is shown in matrix C here. What is the cost of one journey on section G? This question is 1 mark, and it's just to sort of interpret, as we've done a couple times, interpret the information that's actually going on here. So we've got the cost of one journey for E would be this element in row 1, as would for F in row 2 and G in row 3. So we can clearly see that the cost for a one journey trip on section G is $2.87. Three B says that Kim travels once on section E and then twice on section G. So his total cost for this day can be found by multiplying M by C, where we've got M as a 1 by 3 row matrix, and we want to find out what are the values of A, B, and C. So what we've got here is we've got M times C, which is ABC multiplied by our C matrix, which has our 3 values here. I might just do the letters rather than the numbers. That's a bit easier for me. So E, F, and G. That's our matrix there. So we want to find out what is the total cost. Well, this matrix product, M times C, it's going to be a 1-by-1 matrix, but I want to know what's actually going to be going on here. So we've got Kim travels once on section E. So whatever the cost is for section E, we want to multiply that number by 1. So we know A is actually going to be 1. It's going to be 1 times E. Then we know that Kim travels twice on G. So he hasn't traveled anywhere on F. So whatever the F value is, we want to multiply it by 0. So B is going to be 0. And finally, as the question said, he travels twice on G. So this G value needs to be multiplied by 2. So that leaves C being 2. So we end up with A equaling 1, B is 0, and C is 2. Question 4. We've got this travel company, which is studying the choice between air, land, sea, or no travel by some of its customers each year. This transition matrix shows the percentages of customers who are expected to change their choice of travel from year to year. SN will be the matrix that shows the number of customers who choose each type of travel n years after 2014. So therefore, the state matrix for 2014 will be the initial state matrix S0, which we see here. Matrix S1 is shown here, and remind ourselves that S1 will refer to the year 2015, so 1 year after 2014. It shows the number of customers who chose each type of travel in 2015. Yep, says it right there. We've got for air, it's 478, but we don't know the values for land, sea, or no travel. We want to find out what are the missing values. So what is D, E, and F? This is just a transition matrix problem, which we can do in our calculator. So if we check our notes on transition matrices, we can use our rule is in the form of Sn plus 1 is equal to T multiplied by Sn. So because we're starting off the state matrix, we know that S1 will be T multiplied by our initial state matrix. So that's what we need to get into our calculator. Now that you've got your T matrix and your initial state matrix in here, we know that S1 will be T multiplied by that initial state matrix. And sure enough, thankfully, we get the same number for A, so we know we've done it right. And we have D is 298. We have E as 94, followed by F is 130. Part B of this question says, let's consider the customers who chose sea travel in 2014. How many of these customers were expected to choose sea travel again in 2015? So this question is about interpreting what this transition matrix is saying. So if you have sea travelers this year, what percentage of those sea travelers will choose sea travel again next year? So you're looking at where column S intersects row S. So this number here represents the percentage of people who chose sea travel this year and are still going to choose sea travel next year. 0.25 as a percentage is 25%. So what it is, it's 25% of the sea travellers, but it doesn't ask for the percentage, it asks for how many. So we know that 80 people chose sea travel in 2014. So what this is really asking is, what is 25% of 80? As I like to do it, I could say 25% of 80 is 20. So I know 20 people were expected to choose sea travel again in 2015. Let's consider the customers who are expected to choose air travel in 2015. What percentage of these customers also had chosen air travel in 2014? This is a bit of a two-part question. What it's saying is, what percentage of these customers had also chosen air travel in 2014? So what we've got is, in 2015, there were 478 people who chose air travel. We want to know, of those 478 people, how many of them also chose air travel in 2014? So what we want to know is, of these 2014 people, how many of them chose air travel again? So there was 520 people in 2014 that chose air travel. How many of those people are now included in the 478? So what we want to ask ourselves is, 65% of air travelers choose air travel again. So it's the intersection of A with A. So 65% of the 520 people will choose air travel again in 2015. Now, if you work out 65% of 520, it's 338. So 338 of those 478 people did choose air travel in the previous year. So 338 out of the 478 were air travelers in 2014. So what we want to work out is, what is 338 out of 478 as a percentage? Well, the way we can work that out is, if you take 338 and divide it by 478, then you multiply it by 100. That will give you your percentage. So when you put that in your calculator, 338 divided by 478, then you times it by 100, up to the nearest whole number, you get 71%. So a bit of a tricky 1-mark question, that one. In 2016, the number of customers that were studied was increased to 1,360. So this new matrix contains the number of customers who chose each type of travel in 2016. So that's kind of our new initial state matrix, I guess. The company intends to increase the number of customers in the study in 2017 and in 2018. The matrix that contains the number of customers who are expected to choose each type of travel in 2017 and 2018 can be determined using this recurrence relation rule. We've got the same T matrix. That's another reason why it was handy for me to actually define this as matrix T, because I can use it again. And now we've got this new B matrix. We've got the element in the fourth row of matrix B is -80, so that's here. Now what we're going to do is explain this number in the context of selecting customers for this study in 2017 and 2018. So in the fourth row here, it's the letter N. Now let's remind ourselves, the letter N is denoted by people who do not choose to travel, so they're choosing no travel. So the number of people who are not choosing travel is going down by 80. Now, because the number of people who are not choosing to travel is going down from year to year, what this is saying is each year the company is, I guess, ditching 80 people who are not traveling for the study. So they're just choosing to take them out of the study. So for 2017 and 2018, the company is no longer studying 80 people who chose not to travel. 4E is determine the number of customers who are expected to choose C travel in 2018. So we're going to have to use these recurrence relations. So we've already got T defined in here. What I will need to do is we're no longer using this initial state matrix. We're using this 2016 one. So what I might do is let's get this in. I might call that, say, R16 for R of 2016. Okay, that's not that. Maybe just R. Cool. We'll leave it as R. Now, I also want to put my B matrix in. Got 80, 80, 40. Now, we've already got all the matrices we need. Now we're just going to solve for R of 2014. We're going to need to go step by step in order to get to 2018. So to get to R 2014, it's T multiplied by our R matrix, the R 2016 one. We add matrix B. All right. Now, because I like to define the matrices, I'm going to retype this one out. And maybe I'll just name that R2 because it's the second R I'm using. R1. No, it doesn't like it for some reason. Maybe instead of R, what can I call it? Maybe just P, just something random. So I'm going to define that as P. And now to work out R of 2018, it's T multiplied by the P matrix. So that is my 2018 state matrix. Now, the question asked the number who are expected to choose C travel. So C travel is the third row. So rounding to the nearest whole number, that is 190 people. So in 2018, 190 people chose C travel. 5A for 1 mark. Junior students at this school must choose one elective activity in each year of the 4 terms in 2018. Students can choose from the areas of performance, sport, or technology, and this transition diagram shows the way in which these students are expected to change their choice of elective from term to term. Part A says, of the junior students who choose performance in one term, what percentage are expected to choose sport the next term? So we're just trying to interpret this diagram. So if they choose performance one term, the percentage that then go to sport, so we're looking at the arrow that goes from P to S, we can see that's clearly 40%. So question 6. We've got the matrix below shows the result of each match between 4 teams, A, B, C, and D, in a bowling tournament. Each team played each other team once and there were no draws. The most dominant team is found using a two-step dominance. We want to find out which team is the most dominant and briefly explain how you calculated it. Remembering two-step dominance, let's have a look at dominance in our notes and see what we can find. Right, we've got dominance here. So we've got our regular dominance matrix, and if you want to find the two-step dominance, you just find d squared. And the total two-step dominance is found by summing the rows up. So for example, here, B has a two-step dominance of adding up 1, 2, and 3, which sums to 6. You can find the total dominance, however, by finding D plus D squared. So if you find D plus D squared, you get this matrix. And when you sum up all the rows of these matrices, you get the total dominances here. So in this case, this B player was the most dominant. I guess it was Bob. So we're going to do the same thing. We've got our dominance matrix there. As always, let's get it in the calculator. I'll define it as D, and all I need to do is find D plus D squared. That's going to give me that matrix there. Now, who is the most dominant? Well, let's sort of just work it out quickly. So it goes A, B, C, D going down. A has a total of 3. B has a total of 4, adding up the row. C has a total of 5, and D has a total of 2. So C had a total dominance of 5. So C is the most dominant player. Team. Now, briefly explain how we calculated it. Well, what we did was we calculated the total dominance, total two-step dominance, using D plus D, and to show squared, you can write this little caret, and then sum the rows. That's all we needed to do. Question 7. We've got a 2,700 kilometer highway has a maintenance schedule that changes from year to year. The sections of the highway can be graded, resurfaced, sealed, or no maintenance. Now, for these 2,700 kilometers of highway, the matrix recurrence relation shown here can be used to determine the number of kilometers of highway that require the different types of maintenance. So we've got our initial state matrix, so the initial kilometers that need these different types of maintenance, and our transition matrix. Finally, our B matrix here as well. And just noting that the initial state matrix is the maintenance schedule for 2020. We want to know, what is the value of K in matrix B? Now, to answer this question, you need to really think about the problem, about what's actually going on here. So B, what's going on is it's deciding whether you're increasing or decreasing the number of kilometers of highway that need these different types of maintenances. Now, the highway is not getting longer, right? So they're not actually, they're only grading, resurfacing, sealing, or doing no maintenance. So they're not actually building new highway. And similarly, they're not destroying any of the highway. So what I'm saying is the highway still needs to be 2,700 kilometers. It needs to stay the same amount of highway. That means that summing up all the elements in B, they need to sum to 0. A quick example of this might sort of refresh and explain why. If we remember back to our notes about the car rental company, so what is actually going on here? So remember the car rental company, what they were doing is they were adding one car to each location each week, and that meant that the B matrix in this occasion was 1, 1. So what's going on here is every week or every iteration of this rule, they were adding 2 cars, so 1 plus 1, 2 cars into the system, such that after 2 weeks, there were then 42 plus 52, there were 94 cars in the system when they only started with 50 cars. So similarly, if we're not actually adding any kilometers of highway, these numbers have to add to 0. So if you take k plus 20 plus 10 minus 60, and you know that equals 0, you can probably think about it in your head, k is going to need to be 30 for that to work out. K is equal to 30. For another 1-mark question, how many kilometers of highway are expected to be graded in the year 2022? We're going to need to get these into our calculator once again. All right, now I've defined my transition matrix, our initial state matrix, and B. So I know that M1 will be our transition matrix multiplied by the initial state matrix plus B. So that is T1. Now remember, that's M1. If M0 is 2020, to get to 2022, we're looking at M2. So that's M1. We need to do this iteration one more time. That gives us M2. So that is the 2020 matrix, and highway for graded is the first element, so that's 457. So 457 kilometers will be graded. And the final question, question 8, we've got a matrix product, we've got a permutation matrix multiplied by a column matrix, which forms the word leaks. I think we have discussed this one already in previous RLTs, but we'll do it again. So think about this matrix multiplication. You're going to have 0 times L plus 0 times E plus 0 times A plus 1 times P plus 0 times S. So notice that all the letters were multiplied by 0 apart from P. So P is the only letter that was multiplied by 1. So what we're saying is P will be the first letter. So it's got to either be C, D, or E here. Let's think about what the second letter is going to be. We've got 0 times L, 0 times E, then 1 times A, and then 0 multiplied by P and S. So the second letter is going to be A, and immediately that actually knocks out C and E. So we know the word is going to be pales. If you wanted to keep going to double check that it went L, E, and S, you could. But we know the answer is D.